Biopolymers. Recently, biopolymers have been getting a lot of marketing hype due to increased attention on sustainability. If you pay attention, especially with biopolymers, you will see many of the same faults that other materials have when it comes to sustainability. The name itself generates interest from people looking for sustainable solutions. Here's an example of some of the names out there. And please do not assume that the companies I'm naming have a bad reputation or they have a bad product. That is not what I am saying. What I am trying to do is make you look and see how the name affects how you feel, think, and perceive a product due to the company name or the product name. First one, Earth Visions. Second one, Green Dot, EcoPure, Nature Works, EcoVia Biopolymers. They all induce the feeling of sustainability, green, good. They make you automatically go, wow, this is what I've been looking for all along for my application. Where there's a lot of confusion is the definition of biodegradable and compostable. Biodegradable is a substance or object capable of being decomposed by bacteria or a living organism. Definition for compostable is a mixture of various decaying organic substances such as dead leaves, manure used for fertilizing soil. It's kind of hard to see the difference and seems basically the same, when in fact they're very different. Remember, all things are biodegradable, given enough time. Even oil-based plastic, glass, nuclear waste, all will eventually be broken down. The problem is the amount of time versus the rate of use, which is not sustainable. Compostable and industrial compostable are different than biodegradable due to the fact composting is describing an event under certain conditions that will more rapidly increase the biodegradable process. You see the difference? When it comes to composting, we need to be aware that if you're one of the few people who have a compost in your backyard, that these are very different compared to your local municipality industrial compost pickup. Industrial compost deploy various scientific methods of decomposing the waste at an accelerated rate versus your normal backyard compost. Biopolymers out of the four main material topics is the one category that needs attention placed on the words the manufacturers use. Not only does the name lead to many common misconceptions, but some companies try to mislead by using language such as bio-based, biological, and earth-friendly in their marketing. Despite the rapid growth, biopolymers and biodegradable plastics have not received much attention with regards to waste stream economic analysis. Biopolymers make up less than 1% of the global plastics market and are only expected to grow 2 to 3% in the next decade. In general, the public has a misconception that all biopolymers are plastics that can be just thrown in the trash and they'll magically disappear either in a landfill or their backyard for that matter. This totally diminishes the efforts being put into properly recycling them. In fact, most biopolymers do not decompose spontaneously under a natural environment, but instead require specific conditions such as an industrial composting facility. One must also consider that not all biopolymers are compostable. Biopolymers are typically based from natural resources or a fossil fuel origin. Biopolymers can be made from natural raw materials such as canola oil or sugarcane. The process to produce bioresins is sustainable, but may or may not be compostable. This makes it very complex and costly to properly manage biopolymer recycling or waste streams because they are not all created equal. We must also consider not all bio-based polymers are 100% made from bio-based sources. Some are actually made from petroleum-based components or a combination of the two. Properties of bio-based materials typically are similar to petroleum-based resins, and you will see no real change of performance. Many bio-based polymers are tailored to a customer, and there are not numerous stock grades available. And due to the size of the industry, a biopolymer many times is custom formulated for a specific project. One of the other things I wanted to do was bring up about specific gravity, as I talked about in the very beginning, and I've got an example here. And the specific gravity of PLA and PHA and type materials is approximately 1.24 for PLA, and PHA is around 1.3. So besides the cost per pound increase, you need to compare the weight difference cost when compared to PP. Because there is a difference not only cost per pound, but also in the weight of your product. So if we look at this example, to make it simple and easy, I put the three different materials, the three different specific gravities, and I made all of them weigh the same, and for argument's sake, I made them all the same price. You'll see PLA over PP is 32% heavier, and PHA is, when compared to polypropylene, is 38% heavier. If the plastic part made from PP, the cost would at 90 cents, your cost would be about 25 cents. In PLA, that jumps to almost 33, and in PHA, it goes to about 34 cents. This is only an example on waste versus cost. I'm not implying bio-based materials are too heavy to use, but as with all the materials we're discussing today, it is a balance of cost and your sustainable message. Another factor to take into consideration is supply. As stated, the supply side for materials is dependent on the number of producers, the land available to be dedicated to supply of feedstock and materials. So when it comes to land, let's look what it takes to make 1 ton of material from various feedstocks. So if we look at the two of the most popular feedstocks, corn and sugarcane, when it comes to land use, the chart is best case scenario and does not represent all feedstocks for biopolymers. What we can derive from this is we should have enough land available. The issue we are seeing is, once again, regulation and restricting have not caught up due to deforestation to plant more crops. We've already seen this take place in Brazil recently due to the tariffs imposed on soybeans. Brazil saw a tremendous increase in demand for soybeans and started cutting down more forests for more soy meat planting. Another issue is transportation of the feedstocks. The land used is not close to a port, and a major fight is broken out between the growers and the people fighting to stop deforestation. Has increased even more so due to the proposed new rail line, which will require even more trees to be cut down. Once again, balance. So we must remember, as a people and their governments, we collectively need to look at all aspects of sustainability, not just the name of the material or which one makes us feel better. Considerations for bioresin. Number one, consider where your product may be sold and do. They provide readily available solutions for depositing bio-based resins for recycle or industrial composting. In other words, where you want to sell it, do they actually have recycling programs for bioresins in that area? Look at what stock material options are available, as well as the number of pounds available. in your area. Make sure you understand what kind of bio-based polymer you are buying. There are grades which are combined with petroleum-based materials as well. Is it biodegradable, bio-based, or compostable? They are not all one and the same.